Question 5M. I like 5M actually. It says 3 quadratic functions are given below. First function's an equation. Second function is in table form. And third function is in graph form. For some reason, students seem to think that all 3 of these are just the representations of the same function. They are not. These are 3 different functions given 3 different ways. Real pain in the butt, I know. The question is down here though. Which of these functions have the same vertex? Now, this is a vocab question. It's asking about vertex. It's asking about quadratics. The first place you should look for vocab and parts of a quadratic is graph form. Fortunately, we have a graph, so this is where our conversation is going to start. Where is the vertex on a quadratic equation, on a parabola? Where's the vertex live? The vertex is the elbow in the letter V, the bottom of the V, the elbow, whether it's, I can't figure out how to get the camera right. That's at the bottom or the top, depending on it. So on this one that we're looking at, the elbow is right here. Now, the vertex is a coordinate. It's a location. So actually, it's that little point right there. What are the coordinates of that single point right there? What, comma, what? So right now, count on your book or count on the screen. What, comma, what? -2, comma, 5. So that's the vertex for him. The question is saying, which of these have the same vertex? So you can kind of see how this question is going to go. We got to get the vertex for all of them, and then we decide which pair or grouping of them have the same vertex. Truth be told, I don't like questions like that. I think it's kind of a cheap trick, but whatever. So graph 3, we know the vertex of him. Let's go to the table now, and then we'll do the equation at the end. The vertex. Actually, you know what? Let's talk about 1 first, because I think it's going to help with our conversation for 2 first. So the vertex is the elbow. They give me an equation. I wish I could see this. What should you grab? Calculator. So take your calculator. I want to graph it. I want to see the vertex. What do I click? Y equals. And now we're going to type in the equation up in 1 into y equals into y1. So I'm going to type in parentheses x plus 2 squared plus 5. So parentheses x plus 2 parentheses squared plus 5, just like they gave it to me. And now to get the picture, I click which button? I click graph. And then you got 2 choices. I'll show you, well, I'm going to show you both anyway. Vertex is the elbow. We can see the elbow. Let's eyeball it. It's about right here. If you can count the little hash marks, that's fine. You can't always. Sometimes if you click the trace button, it brings Mr. Spider in, and you can move Mr. Spider, and at the bottom he tells you the coordinates he's sitting at. So if I move Mr. Spider to the elbow, he'll give me an approximate answer, which is -1.96, comma 5. So we'll say -2, comma 5, and -2, comma 5 matches him. So we have enough evidence to believe that the first equation, the vertex, is also at -2, 5. Now, Mr. Spider can be confusing. So another way we can see the vertex in here is, how do I look at coordinates again? Click what? Click what? To look at points, coordinates. Second graph. Now with parabolas, do you remember what we were looking for in the outputs in the blues? There's something we looked for when we graphed these. Something's happening. What was it? The rainbow. You're looking for repeat numbers. So looking in the outputs, and again, on the Regents, it's not going to be at like -200 or 400. It's going to be between like -20 and 20. So if you're clicking around looking for the rainbow, you're looking the local area. Don't go too far up or too far down. So I found it. It's right here. So walk your way in to all of the pairs. So I see pairs at 14, right? 14 and 14, and we're going to walk our way in. 14, 14, 9, 9, 6, 6, Walla Walla, right in the middle. The only dude who does not have a pair is your vertex. -2, comma 5. So now I know for sure that the vertex for that first equation is also -2, comma 5. Woohoo. So I know 1 and 3 work. In little test-taking strategy, if any of these choices down here don't say 1 and 3, we can cross them off. So look at choice 1 here. It says 1 and 2 only. Nah, 3 works. I think that's the only one we have evidence right now to include. Well, actually, no, we can get rid of 2 as well, right? It says 2 and 3 only. We don't know quite about 2 yet, but we know 1 works. We know 1 has to be in the club, so it ain't going to be choice 2. Now it just comes down to whether or not the table works. Now, the table is giving you the print screen from a calculator, kind of. It's giving you the rainbow to look at. So g of x are my outputs. So look, -3, -3, 2, 2, 5, 5. Do I have a middle rainbow number that doesn't repeat? I do not, which means the vertex is not in this table, but the vertex does exist. The vertex does not repeat. People would say, well, Mr. K, look, 5 is in the middle, so it's got to be the vertex. No, it's not. Does 5 have a repeat? Does 5 have a twin? He does. That's not the vertex. The vertex does not have a twin. Look at the graph here. Does this have a second peak to it? No, there's only one top. So the vertex actually happens for this table, for this function, at probably -1.5. Actually, definitely -1.5. So the real middle is probably happening at -1.5 comma 6. Okay, there's no rule that says that your vertex has to happen at an integer value. So -1.5 comma question mark. I know it's not at -2 though, for sure. It's not. It's between them. So graph or table 2 does not have a matching vertex. So only 1 and 3, which would be choice 3. 1 and 3 only. Vertexes happen at one place, period. I'm not 100% sure where it happens in table 2, but I know it's going to be between -1 and -2 because it has to be between all of these pairs. It's going to be a decimal for sure. Okay, tricky question, fun fact, a lot of good things in here that are good to remember for quadratics. So choice 3, did I put 3 up here? Nope. Choice 3, that's it.